this lesson, we're going to talk about polar coordinates. All right, so here we have O, and we call that little part the pole. And we have theta, which is our directed angle. All right, and we have this, which would be like our polar axis. And we have our directed angle here, and then we have a point that is the r comma theta, all right? And then r represents your directed distance. So this is how far out you are, so your directed distance, and this is your directed angle, which would be from where you started here to where your point is at, so the in-between part. And this is technically wrong, but when you do polar coordinates, you kind of have these rings. So it's like you have like one ring and then another ring and then another ring. So the directed distance would be, if this is the pole, so this would be a directed distance of 1, 2, and 3. So you could kind of view it as like the rings, okay? So this point can actually have multiple representations. So let's say that I was graphing the point 3, negative 3 pi over 4. So I would go out to the third, we'll say ring, my directed distance is 3, and then go 3 pi over 4 in the negative direction. All right, so that would be, say, somewhere in here. Now, the thing is, if I want to get another point there, I can do what I normally do to get a coterminal point and add or subtract 2 pi from that number right there. I could still be on the third, like a directed distance of 3 out, and I could get a multiple representations from this point just by adding 2 pi to this number or subtracting 2 pi or any multiple of 2 pi. All right, so here we have our unit circle, all right, and I have labeled what we normally have here. Okay, sorry it's a little stretched out because of my computer screen. So let's say we plotted the point 3, negative 3 pi over 4, that is number 1. I would start at my pole and I would go 3 in the positive direction, and then instead of going a positive 3 pi over 4, which would be through the first quadrant and halfway through the second quadrant, I'm going to go the same distance, but I'm going to do that backwards. So I would go through 1, 2, so 1 quadrant and halfway through, and that would be the point 3 pi over 4. So I'm going to call this point number 1. So point number 1 here is the point 3, negative 3 pi over 4. So let's say we'll call this point 2. All right, so for point, well, there we go. So for point number 2, let's say that I'm going to graph, let's say 4 and pi over 4. So I'm going to go out 4, so my directed distance is 4, 1, 2, 3, 4, and then I'm going to go a distance of pi over 4, which would be right here. So we'll call that point number 2. So let's say that I give you a negative directed distance, so maybe we'll call this point number 3, and we're going to go negative 2 pi over 3. All right, instead of going 2 rings to the right, I'm going to go 2 rings to the left, but then I still move a positive distance of pi over 3. So if you think about going a normal distance of pi over 3, like if I had went 2 rings in this direction, pi over 3 is in the first quadrant. All right, so if I go to pi over 6 and then pi over 4, and then the next one is pi over 3. I would do the same thing over here. All right, it would be 2 rings to the left, and then I would go a distance of pi over 6, pi over 4, pi over 3, and that's where my point is right there. So this would be point number 3. Let's do one more. So we'll call this point number 4. So let's say I have a negative 5 and then a negative 5 pi over 3. Now here's where, normally the mess ups come. Let's say that, let's say I had a positive 5 and a positive 5 pi over 3. I would go 5 rings, And then I would go around until I go a distance of 5 pi over 3, which would be here. Okay? Now, instead of doing that, if I go a distance of 5 pi over 3, that is 1 quadrant, 2 quadrants, 3 quadrants, and then it's the first one in the 4th quadrant. So if I were to go 1, 2, 3, 4, 5 directed distance out, instead of going to this direction, which is positive, I have to go backwards and go 1 quadrant, 2 quadrants, 3 quadrants, and the first one in the 4th quadrant backwards. So this is point number 4. So I'm going to say that one more time. I'm going to go 5 rings out, and then I'm going to go a distance of 5 pi over 3 in the negative direction. So that's 1 quadrant, 2 quadrants, 3 quadrants, and the first in the 4th quadrant. All right, let's do one more. That's a double negative. So let's go negative 6, negative pi over 6. All right, so pi over 6, that is just, if I was going to go a positive distance of pi over 6, that would be in the first quadrant, the first one that I come to right there. So I'm going to go 1, 2, 3, 4, 5, 6, and I'm going to go backwards pi over 6, so that would be the first one in the first quadrant backwards. All right. So that is how we graph points. Now, you can convert your coordinates from polar coordinates, which is the r theta, into rectangular, which is x and y. All right, so the r is always first, or theta is always second. So when I convert my x, if you think about it, when you look at your points on your unit circle, those are always x comma y, and cosine goes with x, and y goes with the sine. All right, so from going from polar to rectangular, I can find the x value of the point by doing the directed distance times cosine of the angle. And to get the y value, I would do the directed distance times the sine of the angle. So here's my pole, or my origin. This is my x value, also known as my polar axis here, is right here. So this is the x-axis. So this would be the x, this would be the y, and here's the point, right? Whereas the r value gets you to the point, that's your directed distance, and theta represents the angle measure here. All right? So let's, when you go from rectangular to polar, all right, you're going to do a tangent of the theta is equal to your y over your x, and you would have to solve for theta. So I would prefer to write this as an inverse so that theta is already by itself. So theta is the tan inverse of y over x. And to find your r value, it's literally the Pythagorean theorem. The x squared plus the y squared equals the c squared. So I'm just going to square root x squared plus y squared. So let's find some conversions here. So we're going to go from polar to rectangular. So my r value is 2, and my theta is pi. So to find the x value, remember x pairs up with your cosine. So I would have r, which is 2, times cosine of my angle. And then for your y value, it's r, and then times the sine of the angle. So if we pull up our unit circle here, I first want to find the cosine of pi. So here's pi. Cosine is my x. Sorry about that. Cosine is my x value here. So the cosine of pi is -1. All right. So I'm going to change cosine of pi to -1. So that means that my x value is 2 times the cosine of pi, which is -1. So I get -2. For my y value, I need the sine of that. So sine of pi would be the y value, which is 0. So this would be 2 times 0, which is 0. So my rectangular coordinates are -2, because that's the x value, and 0, my y value. So same thing here. My r value is the square root of 3, and and my theta is pi over 6. So to find the x value, I will take the r value times the cosine of my theta, and then I'm a little space there. Then my r value times the sine of my theta. So we need to find the cosine and the sine of pi over 6. So if I look at pi over 6, cosine would be the x value, so that would be square root of 3 over 2. So I have negative square root of 3 times the square root of 3 over 2. That's going to give me, oh, I don't know why I put a negative there. You guys might be wondering that as well. Probably because I can't read my own handwriting. My bad. Those are not negative. They're obviously positive. All right, so I get square root of 3 times the square root of 3 over 2, which is going to give me 3 over 2. So that's my x value. And then I do the same thing here. So I have square root of 3 times whatever the sine of pi over 6 is, which in this case, if you look at pi over 6, sine would be the y value. That would be 1/2. So square root of 3 times 1/2, which gives me square root of 3 over 2. So my rectangular coordinates would be the x value, which is 3/2, and the y value, which is square root of 3 over 2. They're not always nice, neat numbers. All right, so now let's go the opposite direction and do rectangular to polar. All right, so if I want to figure out what theta is, I'm going to take the tangent inverse of the y over the x, which remember, tangent is y over x, so that should be pretty easy to remember. So you have 1 over negative 1. So that gives me the tangent inverse of negative 1. Now, it is important to note that sometimes there's more than one angle that give you that. For instance, remember, tangent is y divided by x. So if I get a negative 1, I would take the y and I would divide it by the x, which means I'm getting negative 1 here, but I'm also getting negative 1 for this, because negative square root of 2 over 2 divided by square root of 2 over 2 is also negative 1. So I actually have two options. So you're going to have to pay attention to where your original point was at. So if I went negative 1, 1, I would be in the second quadrant. So when I'm choosing between the two, I already know I'm in the second quadrant, so this is not an option. So it would be the 3 pi over 4. All right, so that is my angle. So that gives me a tangent value of negative 1. So theta is 3 pi over 4. And then to find r, remember you're just going to take the square root of x squared plus y squared, which gives me the square root of 2. So my polar coordinates would be the r value, so square root of 2, comma, the theta, which is 3 pi over 4. So that would be the same location as this point right here. So same thing here. I'm going to find my theta first, so I'll do the tan inverse of y over x. Now, I can't divide by 0, so I'm actually looking for an angle that gives me a tangent that is undefined, meaning I'm dividing by 0. So if I look at the options here, y divided by x, where there's a 0, would be pi over 2 and 3 pi over 2. And again, I need to know which one matches up with the point that I started with. Well, my point is at 0, 2. So if I plotted the point at 0, 2, that would be up here. So when I think about which of these goes with that, it has to be this one, because my point is not down here, okay? If you think about this as like the y-axis and this is like the x-axis, okay? So I know that it is pi over 2, so my theta is pi over 2. So to find my r, I'm going to take the square root of 0 squared plus 2 squared. So my r value is 2. Therefore, my polar coordinates are 2 comma pi over 2. So let's take a look at number 6. So I've got theta is equal to tan inverse of y divided by x. So the tan inverse of 1. Now, I already know that the point -3 is in the third quadrant. So I'm looking for an angle in the third quadrant that has a tangent value of 1. Well, the only way I get a tangent value of 1 is if I divide two of the same things. So my angle is the 5 pi over 4. And then to find my r value, I will take the square root of the -3 squared plus the -3 squared. So my r value ends up being 3 square roots of 2. So that would be 3 square roots of 2, comma 5 pi over 4.